this video, we're going to have a look at anti-differentiating this special case of a reciprocal function. And I'm going to start off with a common misconception. So I'm actually going to start off with a common easy example. Okay, we're going to start off with a, let's do an example of the integral of 1 over x squared dx. One of the ones from a previous lesson, from Antidifferentiation 1. So that's just a power function. So what I mean by that is, if we wanted to anti-differentiate that, we would say, well, the integral of x to the negative 2, and therefore the integral of that, the antiderivative of that, is going to be increase our power by 1, divide by our new power, put a plus c on the end, and of course I can write that antiderivative as negative x to the negative 1. Or you could write it as negative 1 over x. Either way, that's fine. Now that's quite easy, no drama, that works. What doesn't work is when it is just an x on the bottom. Or that thing on the bottom, that whole thing on the bottom just has a power of 1. Okay, so this next one, I'm going to do it in red, because this is an incorrect example of. So here we go. I'm going to do this antiderivative the exact same way, except this is the mistake. So using the same logic as the first one, okay, I'm going to rewrite this as x to the negative 1. It's going to bring that power up. So the antiderivative, I'm going to increase that power by 1, divide by my new power, and, oh, hold on a second. I'm dividing by 0. That's not right. That's not right. Okay, we can't have that. So that is part of what is making this incorrect. Now, for us to be able to do this correctly, we need to first recognize when we need to do a special case. And that when is clearly when that power on the bottom here is a power of negative 1. Because when we increase that power and we get 0, that's not possible. Okay, that's not going to be what we can do here. So let's now do one more little example. Let's go y dash. Let's go determine y dash if y equals ln of x. What I'm asking you is, what's the derivative of ln x? Okay, well, let's do a harder one, to be honest. Let's go ln of 2x. Okay, I'm not going to change much. So what do? When we do the derivative, we do 1 over whatever's in the brackets, and we multiply by whatever's in the brackets. These 2's will cancel out, and the derivative is going to be 1 over x. Well, well, well. When we go backwards, when we anti-differentiate, we are trying to go from a 1 on x back to whatever the original equation was. So clearly what we can see here is, when we anti-differentiate a 1 on x function, we're going to end up with a log. So now let's do a question like this correctly. So what did the derivative do? Well, the derivative said we want to put the bracket contents on the bottom, put the bracket contents on the bottom, so whatever's in the brackets on the bottom. And then the second thing is we wanted to multiply by derivative of the bracket. So that's what it was when it was a derive. Now we're going to anti-derive or anti-differentiate. We're going to anti-derive, let's do 1 on 3x. We'll anti-derive that. Okay, what I'm going to, with respect to x, okay, so the new steps are, again, we kind of got to do the opposite. We're going to put the bottom into a log, then the second thing is, instead of multiplying by derivative of the bracket, we're going to divide by the derivative of the bracket. So what we're going to get is the integral with respect to x is going to be ln of 3x divided by 3 plus c. Now, there is a different way of doing that, which lets you strip that 3x and that x apart. I will show you examples of that a little bit later, but not right now. All right, there are some more mixed examples, and that's going to be the next video, so let's get into it. In this